So 1 AU is the mean distance between the Earth and the Sun. It's about 93 million miles, or 150 million kilometers. This is just a vocab word that we've talked about a little bit. That brings us to the signs of the zodiac. The signs of the zodiac actually do have astrophysical meaning in that the Sun is found projected against the signs of the zodiac throughout a 12-month period. So in this diagram, here we have the Earth going around the Sun. And this is a slice of the celestial sphere that contains the signs of the zodiac. And so in 1 month, let's take the month where, the month of November, the Sun is found projected towards Scorpius. If we take instead the month of September, then the Sun is found projected towards Leo. And so the signs of the zodiac, ignoring their meaning in horoscopes, actually the meaning of them in astronomy is that the Sun is found in those constellations throughout the year. Of course, when we see the Sun in those constellations, it's daytime, right? And so the meaning can be a little bit confusing to students because the Sun, sure, will be found in Leo in September, but you can't see Leo then because the Sun is right there. There's no contrast. So the constellations that we can actually see in the signs of the zodiac are that half in September, right? Because the Sun is found towards this half. Anyway, throughout 1 month, the Sun will actually change one constellation. And that's why there's 12 signs of the zodiac. So the Sun will progress from Leo here in September, over towards Virgo in October, over towards Libra. So yeah, I'm getting confused. There are 12 on average, but I guess they're not spaced evenly. Over towards Libra / Scorpius here in November, etc., etc., etc. So on average, it will pass through one sign of the zodiac every month, and there's 12 signs of the zodiac. So that's the meaning. When people ask what their birth sign is, that's basically where it comes from. Although things have gotten jumbled up a little bit, the origin is where the Sun was on your birthday.
During the day?
Yes.
Okay.
During the day. Yeah, it's a little bit confusing. At some point, ancient astronomers must have had to figure that out. They must have had to look just after sunset or just before sunrise to see that constellation. That's the explanation that I remember. Obviously, don't confuse astrology and astronomy. Astronomy is a real science. That path, the sign of the zodiac, is actually called something. It's called the ecliptic. It is this green line here. When we do the planetarium show tomorrow, I will also put it in green. So the green line is the ecliptic, and then this is the celestial equator. If you can relate this back to our view at the North Pole, when the Sun is found north of the celestial equator along this ecliptic path, that's their spring and summer and early fall. When it's found south of the equator, that is their winter primarily. So if you can imagine this whole sphere spinning, if the Sun is down here along the ecliptic, it will never rise. If the Sun is up here, then it will always be visible.
Were the zodiac signs of the zodiac only in the northern hemisphere, or
No.
were there people in the southern hemisphere that were doing this also?
Were they also doing that? That's a good question that I don't know the answer to. I mean, the signs of the zodiac are very close to the celestial equator. And so we can obviously see them all in the north because the Sun is always visible, all year round we have a view of the Sun. In the south, they probably have their own, well, they definitely have their own set of constellations. I don't know if they related that to the sun's position, though. The Earth is a bit misbalanced in that a lot of the land mass is in the northern hemisphere. So there simply weren't as many civilizations in the south. But I don't know the answer to your question. So the offset here is 23.5 degrees. Offset between those two, and that actually dictates a lot of things about the seasons and whatnot.
The top one is also 23 degrees, right? That's the green is the ecliptic, right?
Ecliptic here, celestial equator here, yeah.
And I forgot what the name of the light green one is.
This one is the celestial equator.
Oh, you haven't talked about the light green one yet.
Oh.
We talked about it yesterday.
Yeah.
Galactic?
It's the celestial equator.
Yeah, the celestial.
Yeah.
That's 23 degrees also.
So
the light green's that's projected on the far side of it.
Yeah, so it's one great circle there. If we think about angles, then this angle in spherical coordinates is 23.5 degrees. It's a little bit funky to talk about angles.
No, I'm talking about the light.
That's the extension of the ecliptic going on the far side of
Yeah.
Oh, that's what that. Oh,
This is a great circle here.
Okay.
And this is the second one.
Okay. Now,
Again, 3D will help.
again.
Yes?
How far off is the moon's orbit from the ecliptic?
So everything in the solar system is close to the ecliptic. The moon is 5 degrees off that. That 5 degrees is important, or else we would have lots of eclipses. But the fact that we don't have any is evidence for an offset between the moon's plane and the ecliptic. All right. You guys have so many questions, which means that we go very slowly. All right, so this is basically information for the last half of that quote-unquote homework that I gave you guys, that the sun's motion takes it through the signs of the zodiac throughout a 12-month period. And we've got some little demos, etc. The important thing here is that different constellations are visible at different times of the year because the sun passes through different parts of the sky. Whatever part of the sky that the sun is passing through is going to be invisible to the naked eye, but of course still visible to a radio telescope.